Okay. So as per the definition, as per the statement of Lambert's law, this first equation is there, minus di upon dx is proportional to the intensity. Now this proportionality constant, this proportionality is here k. K is the absorption coefficient. Okay. So now this equation becomes this equation 1. Then you take this intensity on this intensity side and x to this right hand side. So this equation become now like this. Okay, but there is a very small change because this is the d means the small change is there. So for the analysis it is integrated. Okay, and for the integration it gives some limit. So the limit is I is equal to 0, then x is equal to 0. If I is equal to I, then x is equal to x. So this is the limit for this. Okay, so give this limit to this equation. This equation 2 is integrated with this limit. So this equation become to be integration I0 to I. Okay, is the di upon I is the intensity. Okay, and then is equal to minus k. Okay, into integration x 0 is to x into dx. Okay, this is the integration. So after solving this integration, this equation like this, log of I0, I upon I0 is equal to minus kx. Okay, असं equation आपल्याला मिळतं. But then again solve this equation. आणखी याला आपण जर सॉल्व केलं तर I upon I0 हा log of e जो आहे याला इकडे कन्वर्ट केलं तर एक्सपोनेन्शियल मध्ये जाईल तो. ओके, सो दिस इक्वेशन बिकम टू बी, त्या इक्वेशनला कसं लिहिलं जातं, I upon I0. ओके, I upon I0 then is equal to काय राहणार, एक्सपोनेन्शियल है ना, इकडे लॉग इकडे काढला आपण, इकडे एक्सपोनेन्शियल झाला, एक्सपोनेन्शियल टू द पॉवर k into x, k into x. Okay, हे असं राहील. Then finally solve this equation, that is I is equal to I0 into e to the power minus kx. Okay, this is to be the equation. Okay, after solving this equation you get this final equation, that is I is equal to I0 e to the power minus kx. समझता है? So this equation again stated is here, the intensity of monochromatic light is decreases exponentially because there is a negative sign. So intensity decreases, okay, exponentially with increasing the thickness of absorbing substance. म्हणजे जेवढा जास्त हा x वाढत जाईल तेवढं इंटेन्सिटी जी आहे ती काय होत जाईल, मायनस होत जाईल, डिक्रीज होत जाईल. ओके, पण कशी होते, एक्सपोनेन्शियली. E is there, so that is called as the exponentially. Okay, so intensity of radiation is decreases with exponentially with increasing thickness arithmetically. थिकनेस अरिथमॅटिकली म्हणजे थिकनेस खूप जास्त वाढत असते तर इंटेन्सिटी जी आहे ती कमी होत जाते. एक जनरली एक लक्षात घ्या, आपण टेस्ट ट्यूब घेतो है ना, टेस्ट ट्यूब, त्या टेस्ट ट्यूबची एक थिकनेस असेल है ना, एक त्याचा डायमीटर असेल, बरोबर आहे. त्या डायमीटर मधनं काही मॉलिक्यूल त्या डायमीटर मध्ये येतात, बरोबर. आणि मग व्हेन दिस लाईट इंटरॅक्ट विथ दिस टेस्ट ट्यूब, सो इट इंटरॅक्ट विथ द मॉलिक्यूल. ओके, एक ही कंडिशन है. सेकंड कंडिशन इज देयर, you take the molecule solution or any material in beaker. Okay, so diameter of beaker is greater है ना, त्याचं डायमीटर खूप जास्त आहे, म्हणजेच त्या मटेरियलचं जे काही थिकनेस आहे ते थिकनेस जास्त आहे. ओके, तर बीकरची थिकनेस जास्त आहे, टेस्ट ट्यूबची थिकनेस कमी आहे. त्याच्यामध्ये जर आपण बघितलं तर काय होतं, इंटरॅक्शन झाल्यानंतर काय होतं की ते जे थिकनेस मुळे नंबर ऑफ मॉलिक्यूल जास्त इंटरॅक्ट होणार लाईट सोबत, विथ इंटरॅक्टिंग लाईट. ओके, so this interacting light interact with the more molecule in case of more thickness है ना, म्हणजे बीकर मध्ये जास्त थिकनेस असल्यामुळे जास्त मॉलिक्यूल लाईट सोबत इंटरॅक्ट होणार ऍज कम्पेअर टू टेस्ट ट्यूब. लक्षात येत आहे का? what I am talking with you. Okay, म्हणजे पहा, if increasing the thickness जर वाढली तर absorption जे आहे ते absorption काय होत जातं, it will be increases, it goes on to be increases. ठीक है, thickness and absorption is directly proportional, it increases. Okay, so let me see here. लक्षात येत आहे का? हॅलो.
Yes, sir.
ओके, थिकनेसचं एक्झाम्पल समजलं? ठीक आहे. Next, then after the Lambert, this law is extended by the Beers. Okay, and the Beers apply this law for the liquid compounds. Okay, liquid homogeneous absorbing solution. Okay, Lambert's law is regarding to the solid, and Beer's law is regarding to the liquid compound or liquid absorbing medium. Okay, so again, in case of solid compound, you know that there is a thickness is most important. For solid, X is important, and for the solution, there is a concentration is important. For liquid condition, there is a concentration is valuable thing. Okay, so concentration. So Beers consider the concentration parameter for the absorption and give their relation. Okay, so he stated the law in which he stated that when a beam of monochromatic light pass through a solution of an absorbing substance, okay, what happened? Monochromatic light when incident on the solution, what happened? The rate of decreasing intensity with the thickness, means this ratio, okay, minus di upon dx. Rate means ratio, let me consider here. Minus means there is a decreasing what intensity, okay, that is I, with thickness, that is the x. Okay, so this minus di upon dx means rate of decreasing intensity with the thickness is directly proportional to intensity. Okay, up to this intensity it is the Lambert law, and there additional one term is there, this is to be the concentration. Okay, so rate of decreasing intensity of radiation with thickness is directly proportional to the intensity of incident radiations and concentration of homogeneous solution. Okay, there add the one term is there, concentration by the Beers. Okay, so that's why this is called as the Beers law. Okay, again this after solving this all terms, this equation become to be the I is equal to I0 e to the power again exponentially, then minus alpha c and x. Okay, x is there. So this law is simply considered as a Lambert's and Beers law. Not only Beers law, up to this equation it is to be the Beers law. But if you see this, there to the Lambert-Beers law. Okay, because their x is term from the Lambert's law and c is term from the Beers law. So that's why it is called as to be Lambert's and Beers law. Okay, this equation we get here. Then what happened? We mathematically see some explanation about this. Okay, so very simply, the first one is there is from statement of this Beers, the di upon dx is directly proportional to intensity and concentration is there. There is a minus rate because decreasing in a rate. Okay, then proportionality constant. That proportionality constant is become to be the alpha. है ना. आता इथे जो प्रोपोर्शनॅलिटी याच्या आधी जो लॅम्बर्ट मध्ये होता तो के यूज केला होता, ऍब्सॉर्प्शन कोएफिशियंट. ओके, बट हियर मोलर ऍब्सॉर्प्शन कोएफिशियंट बिकॉज देयर इज अ कॉन्सन्ट्रेशन. लक्षात घ्या, इकडे ऍब्सॉर्प्शन कोएफिशियंट होता फक्त के लॅम्बर्ट मध्ये, आणि इथे काय यूज होत आहे, मोलर ऍब्सॉर्प्शन कोएफिशियंट that indicate it related to the concentration molar. Okay, so there is a minus di, okay, upon dx is equal to, now this proportionality constant is replaced by alpha. Alpha is the molar absorption coefficient, that is the alpha, then I, and then c. Okay, then next part is similar to the Lambert law. Okay, then take this intensity on one side, then minus di upon I, okay, like this is equal to what? There is a alpha Okay, C and then dx. Okay, now there is a change, small change is there, so integrate this equation. So after this integration again there is a I to I0. Okay, so x is equal to 0 and x I is equal to I, then x is equal to x, I is equal to I, x is equal to x. Okay, so in this way we give the limit for the integration. So transfer this negative sign from this side to this side. So we get this integration is there, di upon I, their integration from 0 to I0 to I, that is equal to be minus alpha C, the concentration, integration give to the x, that is x is equal to 0 and here x is equal to x. So this is to be the limit for the x. So this is the integration of dx. Okay. So after solving this equation, we can see here, after solving that, is I upon I0 is equal to, this term is here, it is a log of, okay, is a log of, okay, and then here minus alpha C and x. Okay, you can see here, this equation is here. After this solving, we get this equation. Okay, this one. Then remove this log. Okay, so log, if you remove from this side, so in this side you can add exponential. Okay, so I upon I0, that is equal to be exponentially the power of minus alpha C and x, alpha C and x. Okay, so now here I upon I0 is equal to, I is equal to, you can change this equation like this, I is equal to I0 into e to the power minus alpha C and, लक्षात येत आहे रे पोरांनो? Hello.
Yes, sir.
Now you understand it. This question will be asked on this topic for 4 marks. To derive the expression for Lambert law, for Beer's law, for Lambert-Beers law. Okay. So then you have to solve this in stepwise manner. Okay. लक्षात येत आहे ना? टोटली मॅथमॅटिकल पार्ट नाही वाटला पाहिजे आपल्याला. प्रत्येक टर्म का घेतोय, कशी आली आपल्याला समजलं पाहिजे. Okay. So let me, after solving this all, you get this I is equal to I0 into e to the power minus alpha Cx. Okay, so now we can again state it, this equation is here. Intensity of radiation is decreases, okay, decreases exponentially increasing thickness and concentration. Okay, thickness and concentration increases, the intensity is decreases. You got this point? Intensity is decreases. It's a transmitted in intensity. म्हणजे काय होतं, when some light is fall on the solution or any absorbing material, so what happens, some light is absorbed and some light is transmitted. Okay, some light is reflect, but the transmitted light is here. So that's why transmitted light means what happened, there is a some less light is come out from the absorbing medium or solution. Okay, their intensity is less as compared to the intensity, incident intensity. बरोबर आहे ना? तर ते ती ही इंटेन्सिटी आहे. ओके, दॅट इज आय. सो आय जी आहे, जेवढं जास्त थिकनेस, ओके, थिकनेस जेवढी जास्त वाढेल, जेवढं कॉन्सन्ट्रेशन जेवढं वाढेल, तेवढं काय होईल, जास्तीत जास्त ऍब्सॉर्प्शन ऑफ लाईट होईल. बरोबर आहे. आणि जेवढं जास्त ऍब्सॉर्प्शन होईल तेवढं हे काय होईल, डिक्रीज होईल है ना. तेवढी कमी ट्रान्समिटेड इंटेन्सिटी आपल्याला बाहेर पाहायला मिळेल. बरोबर आहे ना. So that's why we can state this equation. Intensity of this radiation is goes on to be decreases exponentially with increase exponentially decreases with increasing thickness and concentration. You got this point? Then आणखी याला पुढे थोडं जर सॉल्व केलं तर log of I0 upon I, हे बघा, this is to be the absorption. Log of I0 upon I is equal to, हे दिसत आहे का इथे? ही टर्म दिसत आहे का? पहा, आणखी याला पुढे जर आपण सॉल्व केलं या इक्वेशन नंबर 5 ला, इक्वेशन नंबर 5, तर याला लॉग आपण बघितलेला आहे. आता नॅचरल लॉग ला लॉग बेस 10 मध्ये जेव्हा आपण कन्वर्ट करतो, then you can write down this in this way. Okay, so now here log of I upon I0 is equal to minus alpha cx, आणि हा जो काही 2.303 आहे हा इकडे ट्रान्सफर होऊन जाईल. ओके, so now there is minus sign, इथे मायनस साइन दिसत आहे. So remove this minus sign, so replace this I upon I0 is replaced by the I0 upon I. याला काय केलं, उलट केलं. Log of I0 upon I is equal to alpha cx. Okay. Then हे सगळं सॉल्व केल्यानंतर you get this value, this molar extinction coefficient, this coefficient. Okay, इथे जे हे coefficient दिसते ना आपला अल्फा अपॉन 2.303, हे जे आहे अल्फा अपॉन 2.303, ही जी व्हॅल्यू आहे that is equal to be the molar extinction coefficient, ज्याला आपण असं दाखवतो molar extinction coefficient. ओके, हे असं दाखवतो. ठीक आहे, this is to be the molar extinction coefficient. Okay, like here, let's see here. So this equation become the log of I0 upon I is the absorption. It's considered as the absorption. This is the absorption, or also called as the density. Okay, so that equation become to be इकडे alpha prime घेतला किंवा इथं epsilon सुद्धा घेतला. Okay, epsilon c असे दाखवता येतं. म्हणजेच आपण याला काय म्हणू शकतो की absorption is equal to molar extinction coefficient C and X. Okay, you got this point. So this is to be the final equation of Lambert's and Beers law. Absorption is equal to molar extinction coefficient into concentration into thickness. Okay, so this is to be the Lambert's and Beers law equation, and the absorption phenomena, basically like spectrophotometer and colorimeter, they work on this principle. A is equal to molar extinction coefficient, concentration, and X is the thickness. Okay, you got this point? This is to be the absorption. Okay, आता पहा इथे काय होतं, जे absorption आहे, आता molar extinction coefficient is a constant. Okay, is a constant value, and X is also constant because when you work on spectrophotometer or colorimeter, you use the cuvette. Okay, and in that cuvette, the thickness of this cuvette is constant. क्युवेट बदलतो का आपण? नाही, एक सारखीच क्युवेट असते, ज्या क्युवेटची थिकनेस जी असेल ती एक सारखी राहते. ओके, मीन्स त्याची थिकनेस ही कशी आहे, कॉन्स्टंट आहे, म्हणजे युनिट आहे असं म्हणू आपण त्याला. मीन्स एक्स इज ऑल्सो कॉन्स्टंट and this molar extinction coefficient also constant. So what remains, that A is equal to C. So simply is stated that A is directly proportional to the C. Okay, so this is to be the absorption is directly proportional to the concentration of the solution. Okay, जेवढे जास्त concentration असेल तेवढे जास्त काय राहतं, absorption राहतं. You got this point? So in this way, this Lambert-Beers law can be explained. Absorption is directly proportional to the concentration. Okay, concentration increases means C increases, means number of molecule upon volume increases. Okay, so this is C is equal to N upon V. So concentration increases means number of molecule increases. if number of molecule is increases, so their absorption by this molecule is also increases. Okay, so simply this, you can understand A increases, C increases. Now the molar extinction coefficient is there. You can understand to the molar extinction coefficient. The molar absorptivity or molar extinction coefficient may be defined as absorption. Okay, याला कसं define केलं जातं? याला molar extinction coefficient ला absorption for the concentration of 1 mole per liter. Concentration 1 mole and thickness is 1 centimeter. Okay, so for this absorption, okay, molar extinction coefficient, 1 minute. Hello. So we are talking about the molar absorption coefficient. So that A is equal to a molar extinction coefficient and C and X. Okay. So you can define it if concentration at concentration 1 molar concentration is there and 1 centimeter thickness is there. Then both are the unit. Then molar extinction coefficient is directly proportional to the absorption or is equal to be absorption. लक्षात येत आहे का? Hello. 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 You got this point?
Yes, sir.
Okay. Then this is the deviation of Beer's law. You know, sometimes what happen in solution, when you prepare any solution, what happen? There are some impurity may be there. Okay. And due to that, what happened? The absorption train means we know that this A is directly proportional to the concentration. Okay, but concentration is very good, that whatever concentration is there, but if along with the concentration if there is impurity, त्याच्यामध्ये जर काही impurity असेल किंवा जे काही ज्याच्यामध्ये सोल्युशन बनवलं त्यात सॉल्व्हंटचा काही इंटरॅक्शन होत असेल, so because of that their absorption it will be deviate. Absorption it will be deviate from this straight line. ओके, या स्ट्रेट लाईन पासून काय होणार, थोडं त्याचं डेव्हिएशन होऊ शकतं ड्यू टू सम फॅक्टर. ओके, deviation may be there in case of Lambert-Beers law. Generally what happens, absorption is directly proportional to the concentration. The simple is there, concentration increases, their absorption is goes on to be increases, and due to that we get the straight line for the straight line graph for the absorption and concentration. Okay, like here this is to be the ideal. Okay, असं होत नाही, कारण खूपदा आपण जेव्हा वर्क करतो त्यामध्ये थोडंफार डिफ्लेक्शन येतं. मग ते डिफ्लेक्शन काय येतं, डेव्हिएशन काय येतं, बिकॉज ऑफ दिस रीजन. ओके, ड्यू टू द इम्प्युरिटी, इफ कलर सोल्यूट आयोनाइज है ना, हाय कॉन्सन्ट्रेशन ऑफ सोल्युशन, खूप कॉन्सन्ट्रेशन जर असेल सोल्युशनचं तर अनएक्सपेक्टेड रिॲक्शन, म्हणजे आपल्याला करायचं होतं ऑक्सिडेशन, झालं त्याच्यामध्ये रिडक्शन, असं जर झालं तर त्याच्यामध्ये काय होईल, डेव्हिएशन आपल्याला पाहायला मिळतं. देन कंट्रोल्ड एक्सपेरिमेंट कंडिशन, काही कंडिशन आपल्याला कंट्रोल करायची असेल आणि ती आपल्याकडनं कंट्रोल जर झाली नाही, देन इट मे बी डेव्हिएट दिस कर्व. नो मोनोक्रोमॅटिक लाईट, इफ सोर्स ऑफ मोनोक्रोमॅटिक लाईट जे आपण वापरतो त्याच्यामध्ये जर काही डिफेक्ट असेल तर अगेन देर इज प्रॉब्लेम इन अ स्ट्रेट लाईन ग्राफ. ओके, द चार्ट यू विल गेट विथ द डेव्हिएशन कर्व. देन सम इन्स्ट्रुमेंटल प्रॉब्लेम है ना, काही इन्स्ट्रुमेंट मध्ये प्रॉब्लेम असेल तेव्हा सुद्धा काय होऊ शकते, आपल्याला अशा प्रकारचं डेव्हिएशन पाहायला मिळतं. ओके, सो दिस इज ऑल डिटेल अबाउट द Lambert-Beers law. Lambert law, Beers law and Lambert-Beers law and their deviation. Okay, molar extinction coefficient. So these are various terms we are discuss here. Okay, are you understand this all point? And आता जरी समजलं नसेल, but if you have any problem so you can ask me anytime. Okay, next is there. So there is some numerical problem on this concept, Lambert's and Beers law. So their equation, you firstly you understand this equation, keep in your mind. There is a log of I0 upon I. This is to be the absorption. याला काय म्हणतो आपण? Absorption म्हणतो. And that absorption is equal to molar extinction coefficient into C into X. ठीक आहे? Yes sir. आता जे ऍब्सॉर्प्शन जे असतं, ऍब्सॉर्प्शनच्या एक्झॅक्ट अपोजिट काय असतं? ट्रान्समिटन्स असतं. ओके, म्हणजे लॉग ऑफ I0 अपॉन I हे जर ऍब्सॉर्प्शन असेल, सो I अपॉन I0 इज अ ट्रान्समिटन्स, है ना? ट्रान्समिटन्स असतं, हे आपल्याला लक्षात ठेवायचं आहे when we are going to solve this numerical. ओके, इथे आपली मीटिंग जी आहे ती एंड होत आहे. जो पार्ट आपण आता अंडरस्टँड केला, जे इथे आपण डिस्कस केला तो समजून घ्या आणि त्याच्यामध्ये काही प्रॉब्लेम असेल मला विचारा आणि नेक्स्ट लेक्चर मध्ये आपण याचे न्यूमेरिकल सॉल्व करू. ओके, हॅलो हॅलो